So you might have heard that when you have EPGs that have no contracts assigned between them, that no traffic is permitted between the endpoints and the different EPGs. But is that actually true? So here's a trivia question that I posted on LinkedIn. Two EPGs have no contract assigned between them and are part of the same bridge domain. By default, what type of traffic is still permitted in between the endpoints in the two different EPGs? So a lot of people answered B and D. So which one's right? Is it B, no traffic is permitted? Or is it D, ARP traffic is permitted? Let's go take a look. So first I need to explain to you a couple concepts, and then I'm going to show you how all this works in the lab. So if we look at the ACI contracts white paper, we can see that contracts are applied on unicast traffic only, and that BUM traffic such as broadcast unknown unicast and multicast traffic are implicitly permitted. So the major takeaway from this is if two EPGs are attached to the same bridge domain and they do not have a contract assigned between them, BUM traffic between the EPGs will be permitted and will not get dropped due to contract policy enforcement. And if you think about it, this makes sense because every bridge domain is considered to be its own flood domain. Now, one other important thing to note, so even though that BUM traffic won't get dropped due to a contract policy enforcement, there are other settings on a bridge domain that can influence whether or not your BUM traffic actually gets flooded. So notice there are unknown unicast, multicast, and ARP flood settings that you can turn on or off on the bridge domain. So I think a good analogy to remember how a bridge domain actually works is to compare it to a VLAN. And so in traditional networking, a VLAN is its own flood domain. So BUM traffic gets flooded across the VLAN. And a bridge domain is a lot like a VLAN. So a bridge domain is also its own flood domain too. But instead of a VLAN ID, a bridge domain uses a dedicated VXLAN ID. Another thing that makes a bridge domain different from a VLAN is a bridge domain has configuration knobs that allow you to control whether certain types of BUM traffic actually get flooded over the bridge domain. So that was for BUM traffic, but what about for unicast traffic? So when there's no contract across the EPGs and they're attached to the same bridge domain, unicast traffic will get dropped. But there is an exception to the rule. So if we go back to the ACI contracts white paper, we can see that even if there's no contract between the EPGs, ACI still permits the unicast ARP reply traffic. And if we go into the ACI fabric and we run the show zoning rule command on a leaf switch, we can actually see there's an implicit ARP zoning rule that permits unicast ARP reply traffic. And I actually tested all this out in the lab. So here are the web and the app EPGs, and notice they are not contracted to communicate to each other. And notice they're attached to the same bridge domain. And the bridge domain is using the default settings, and notice ARP flooding is enabled. So let's go into the lab. Notice here I'm connected to Leaf A. I'm gonna run this command right here. It's the policy manager stats. And at the very end, I'm gonna egrep for the VRF VNID the endpoints are in. And the VRF VNID is 2326530. So I hit enter. And so this command shows me statistics when certain zoning rules are hit. And notice I can see counters for the implicit ARP zoning rule. So this is the zoning rule that permits the unicast ARP reply. And notice right now, all the counters for it are set to 0. So we'll come back to this command to recheck the counters soon. Next, I open up Putty Sessions to the web and the app servers. Now, it's important to note the web and the app servers, they're in the same subnet. So in order for the web server to communicate to the app server, it's going to need to send an ARP broadcast so it can obtain the app server's MAC address. So first from the web server, I'm going to run the IP neighbor command to view its ARP cache. And the app server's IP is 10.0.1.2, and notice I don't see any ARP entries for that IP address. Next, I'm going to ping the app server's IP address. And when I send this ping, the web server should send out an ARP broadcast. Now, before I run this ping, I'm going to go down to the app server and I'm going to run a TCP dump so we can confirm it receives the ARP broadcast. So the TCP dump is running on the app server. Now I'm going to go back to the web server and run the ping. It should send out the ARP broadcast. And if we look down here, I'm going to stop the ping on the web server. And if we look down here, we can see the ARP broadcast that was sent from the web server. And then the second message here is the app server sending back the unicast ARP reply. All right, from the web server, let's just rerun the IP neighbor command to confirm that it obtained the app server's MAC address. And there we go. We can see the app server's IP address is now mapped to a MAC address. And finally, let's go back to the leaf switch and rerun the policy manager stats command. All right, and we can see the zoning rule that permits the unicast ARP reply traffic was hit. Notice the packet counter is at 1. So this counter incremented from 0 to 1 when the Unicast ARP reply was sent from the app server back to the web server. So let's recap on what we just confirmed. There were no contracts assigned between the web and the app EPGs. The web server sent an ARP broadcast to the app server. And because bum traffic is allowed between EPGs with no contract, ACI sent the ARP broadcast traffic over the ACI fabric. The app server then received the ARP broadcast, and then it responded with a Unicast ARP reply. And since ACI has a rule to implicitly permit the Unicast ARP reply, the Unicast ARP reply made it back to the web server. So going back to our trivia question, the answer is D. ARP traffic is permitted between endpoints in 2 different EPGs that are in the same bridge domain when no contracts are applied. Now, bum traffic could also be an acceptable answer too. And I should put an asterisk here that your settings on your bridge domain will influence whether or not the bum traffic actually gets flooded. Now, if you don't want bum traffic and Unicast ARP reply traffic to be permitted across EPGs that have no contracts assigned between them, you can simply add each EPG to its own bridge domain. And since each bridge domain is its own flood domain, bum traffic will not get flooded between the EPGs. All right, that's all I got. I hope this was useful, and I appreciate you taking the time to watch this video. Thank you.